Have you ever thought about what keeps a jet engine together while it's spinning thousands of times a minute? You just trust that it's, well, perfect. But what if that perfection hinges on preventing flaws smaller than a single human hair? Today, we're diving into the hidden world of microscopic imperfections and why they matter so much more than you might think.
And that question, right there, is really the heart of our entire discussion. I mean, sure, a tiny scratch on your phone screen is annoying, right? But a microscopic flaw in a surgical implant or a turbine blade? That can lead to catastrophic failure. It really does all start at the surface. So, when we say surface, what are we actually talking about? For engineers, it's not just about getting a nice, shiny finish. No, it goes way deeper than that. We're talking about the very foundation of a component's strength and its lifespan. The key concept here is something called surface roughness, and honestly, the best way to picture it is to think of a brand new road. To our eyes, it looks perfectly smooth and flat, but if you could zoom in, way in, you'd see this incredible landscape of tiny peaks and valleys. In the world of manufacturing, those microscopic bumps and dips are exactly where the trouble begins.
This really highlights the two sides of the coin. On one hand, yeah, you've got the aesthetic flaws, the stuff that just doesn't look or feel right. But the real danger, the invisible threat, is on the other side. You see, those tiny valleys can trap moisture and kickstart corrosion. And those little peaks, they create friction and can become the starting point for tiny cracks that can grow and lead to a total catastrophic failure.
Okay, so how in the world do you fight an enemy you can't even see? It's not like you can just tell a machine to, be a bit smoother. It demands a level of precision that is just mind-boggling. To get there, engineers have turned to an incredibly powerful digital toolbox.
And this toolbox is filled with some seriously cool stuff. Think of artificial neural networks, or ANNs, as this brilliant apprentice that learns from every single part it helps make, constantly getting smarter. And then you have genetic algorithms, which are kind of like evolution on hyperspeed, testing millions of tiny variations to find that one single perfect combination. Put them together, and you give manufacturers a level of control that was unthinkable just a few years ago.
And this isn't just theory or science fiction, These tools are already out there, completely revolutionizing manufacturing. Let's take a look at a few real-world examples to see how it works.
So, first up, carbon fiber composites. This material is amazing. It's incredibly strong and light, but it is notoriously difficult to work with. Well, a 2021 study combined these AI tools to find the absolute perfect cutting speed, feed rate, the whole shebang, and the result was a flawless finish that dramatically lowered the risk of failure down the line. Now, the same idea applies to much tougher materials, like alloy steel. With steel, the big enemy is heat. If you generate too much friction and heat during machining, you can actually burn the surface and weaken the material. Another study used these exact same AI tools to find that perfect sweet spot, a cutting speed that gets you a smooth surface without causing any heat damage. And it's not just about the parts themselves. A study from 2023 showed how these optimization methods can also protect the super expensive, high-tech tools that do the actual manufacturing. By fine-tuning the process, you can extend the life of these tools, which saves money and ensures every part is made with the same consistent quality. So far, we've mostly been talking about traditional manufacturing, where you start with a block of material and cut it away. But what about the future? In the world of 3D printing or additive manufacturing, these principles become even more critical. You see, with 3D printing, you're not carving a statue out of marble. It's more like you're building it from the ground up, one microscopic layer of dust at a time, and every single one of those layers has to be laid down perfectly. So here's a quick rundown of how it generally works. You spread a super thin layer of metal powder, and then a high-powered laser zaps it, melting it into a solid shape. But, and this is a big but, if you get the parameters just a little bit wrong, say the laser is too hot or moves too fast, you can end up with tiny bubbles trapped inside the material. It's like baking a cake with huge air pockets in it. For critical part, that's an absolute recipe for disaster.
And the challenge doesn't stop there. Even after the part is printed, the finishing process, like polishing it with a laser to make it smooth, has to be perfect too. In fact, a study in 2021 found that the very process that's supposed to fix the surface can actually create new, even more dangerous flaws if you're not careful. It is such a delicate balancing act.
So what's the next great frontier? If we can already predict and control so much, what's left? Well, the answer sounds like it's pulled straight from a science fiction movie, but it is quickly becoming a reality.
Digital twins. This is where things get really, really exciting. The goal is to move beyond just predicting the final outcome to actually controlling it in real time. Just imagine being able to fix a flaw before it even has a chance to exist.
So what exactly is a digital twin? The simplest way to think about it is this. It's a perfect, living, virtual copy of a real-world machine that exists inside a computer. It's basically like having a crystal ball that shows you exactly what's going to happen on the factory floor a split second before it actually does.
With that kind of power, you can do some truly incredible things. The digital twin can simulate the entire process, spot a potential flaw forming, and then tell the real-world machine to adjust on the fly to prevent that defect from ever happening. It's the ultimate form of quality control. It's more like quality prevention.
So, what does a future of nearly flawless manufacturing actually look like? Well, it means jet engines that are lighter, stronger, and more efficient. It means medical implants that are designed to last a lifetime. Ultimately, it means a world where the things we all rely on every day are more dependable than ever before. The hunt to eliminate the hidden flaw isn't just about making better products. It's about building a better, safer, and more reliable future for all of us.